Jai Jayendra, Namaste and welcome to my channel. Today we are going to solve the 61st question of the problem solving series and the first question of backtracking topic. The difficulty level for this question is medium and this question has been asked in Google, LinkedIn, Microsoft, Apple and many other companies. So in the previous topic recursion we have already discussed the concept of backtracking. So you can go through those questions and this question is print permutation of given string or array. So you know permutation, right? So if there is any number n, alphabet n or the numbers n, then we can have a permutation of factorial of n, right? So like if we have say a string 1, 2, 3 or ABC, so the or ABCD, so we can have like there are n, the size is n, so 4, so 4 factorial is 24. So we can arrange it in a 24 number of ways. So here we can arrange it in 3 factorial 6 number of ways. So the array is given here, okay, and array contains 3 elements for in this example. So we can have its permutation in a vector of vector, like double 2D array you can say, and its answer would be like permutation of this. That means 1, 2, 3 in any order is given. So one would be 1, 2, 3. What would be the other? 1, 3, 2, and different ways of arranging it. Okay, 2, 1, 3, right? And what else? 3, 1, 2, right? And then 3, 2, 1, and I have reached one more. 1, 3, 2, 2, 1, 3, 3, 1, 2, 2, 3, 1, 2, 3, 1 is not come, right? So 2, 3, 1. So these are the 6 different ways, right? These are the 6 different permutation of 1, 2, 3. But how do we solve this, right? So there are 2 ways. We will discuss one of them because that is a backtracking way. Both are backtracking ways, but that the approach which I am telling, its space complexity will be lesser. One way could be that, okay, but what do you think? How do we solve a recursive problem? We find the base case, right? And then we find the relation between the problem and the subproblem, and then we generalize the relation. So if we are given a array n, array of say 1, 2, 3 here, okay. So 1, 2, 3 is the array that is given. So if we think like this, that okay, if we are traversing from here, starting with this element, and then we need to interchange the values, swap the values from other. While swapping, when this element comes to the last element, okay, and then we don't have any other things to swap or change its position, right? This is the first position, this is the last position. That is our base case, the end part, if we are starting from here, right? So that is one thing, okay. Now say when we are here, okay, I'm telling the approach directly. So we are here at 1, and at wherever, in whichever positions we are going to swap its value from 1 to every other elements, okay. So this one permutation is like every possible positions, right, we should have. So this 1 will change from first to second, we'll move it to second, we will move it to third and swap its values, okay. We'll keep on doing it till the size. If the size was 5, then we would have swapped it from 1 to 1, 1 to 2, 1 to 3, 1 to 4th index, 1 to 5th index. That way we will swap. So here if we swap from 1 to 1, it becomes 1, 2, 3. Here we have swapped the first index, okay, and after swapping 1 from 1, the value doesn't change, okay. Now once we have swapped it from 1 to 1, our index goes to 2, okay. Now we swap this 2. What positions we can swap from 2, like we have traveled over here, so we need to go to the right direction. So first we will swap the value of 2 with 2. You will understand gradually what we are doing. We are swapping the value at its position and then going ahead and swapping it. So just stick to the video, you'll understand. So again we swap from 2 to 2, so our value becomes 1 comma 2, 2 is swapped with 2, the same position, and this 3 moves here and we are in this third position. Okay. Now when we are reached here, we can swap 1 2 3 2, 1 2 3. We don't have any other thing to swap here. So we have got the index is completed. Okay. So whatever value was there, whatever we have got, we have added that value to our new vector. Okay, we have got this value. Now coming back over here again, like we do after in the recursion, right? So what we see, okay, we have swapped so we have swapped 3. Okay, this was swapped with 3. Okay, so we can end it over here only. So this 3 has been swapped and this goes to the end and we get the result 1 2 3, right? Because we don't have to swap anything. Now coming from here to here, going back here again, we swap 2 to 2. Now we swap 2 to 2 and then 3 to 3. Now here if we would have swapped 2, okay, one second. So 1 has been swapped with 1, 2 has been swapped with 2, and now 2 will be swapped with 3. Okay, so this 2 was swapped with 2 and we got this result, and then 3 was swapped with 3, so we got this result. Now this is done, we go here, 2 was swapped with 2, now 2 will be swapped with 3. So when 2 will be swapped with 3, so 1 comma 3 comma 2, now we need to swap this, but there are no other elements after this to swap, so we get another value as 1 3 2. Okay, so this is done. Now coming here, okay, here what we do, so here in the beginning we swapped 1 with 1. Now we will swap 1 with 2. So when we swapped 1 with 2, so it will become 2 comma 1 comma 3, right? And this index will be in this index. Here when we swap 1 with 3, so it will become 3 comma 2 comma 1, and our index will be this. Now when we are in this index 2 comma 1 comma 3, we can swap 2 with 2. This will be swapped with this itself, so it will be 2 comma 1 comma 3, and this will be swapped with this one, but this will be swapped after, right? First we will complete this path. So 2 comma 1 comma 3, and then this will be swapped with itself, so it will be just 2 comma 1 comma 3, right? It won't go anywhere again, but this will be swapped here. This will become 2 comma 3 comma 1. 1 2 3 will be swapped. Here again 2 comma 1 comma 3 was there. 1 was swapped with okay, so 2 comma 1 comma 3, this is done, right? Okay, so this is done. This has reached over here, right? So here this will be swapped, 1 will be swapped with 3, so it will be 3 comma 1. Similarly this will be swapped 3 comma 2 comma 1, and this will be swapped as 3 comma 1 comma 2. So this 1 2 3 4 5 6, this will be our 6 ways of permutating this array. So what have we learned? First thing is the base case, that whenever the index reaches to its end part, we add the number to the vector of vector. That is the base case. What is the second thing? We keep on swapping it from its first position to the last position. It is moving here. So first we swap 1 to 1, then we swap 1 to 2, and then we swap 1 with 3. Okay, so first this path will go. Once this is the result has come, then again we from 1 to 3, it has again gone back. 3 was swapped with 3, so this has gone back over here. Okay, backtracked. We have backtracked. Here when this was switched to 1 3 2. Okay, so from 1 to 3 1 3 2 has come. This 3 3 2 has been swapped. We have got the answer. We have again backtracked here. So 2 1. So we have reached this, and then this again we have reached over here, and then we have switched 1 to 2. So 2 1 3. So 2 1 3 has become here, and then this has been permuted, and then again once 2 1 3 has been done, this goes back here. Every time we go back and then interchange it. Okay. So whenever we swap the elements and we perform the recursion, then we again swap it to the same value, so that The new permutation or recursion swapping, whatever is done to the previous object, not this object. Okay, so I hope this is clear. Once I code it, it will be more clear. Okay. So first, what do we need? We need a result, vector of vector, anything, answer or result. Okay, and then what do we need? Vector of vector result, and we need a vector, normal vector, which will push vector of int answer. Okay, and then we call a recursion function, recur permute say. Okay, and we pass the index, that is 0, the array itself, okay, the result array, and the answer array, answer vector, which will be the answer, and we'll go to the result maybe. Okay. Now actually we don't need this answer, right? Because we will just modify the array itself. Okay, so probably we don't need this. We don't need this. Let's just call out recur permute 0 array result. Okay. Now call this function void recur permute. Okay, and void recur permute, we have the index, int index, and then we have the array, vector int ampersand array, vector of int, and the result. Okay, and we define it. If index equal to array dot size. Okay, if index becomes equal to array dot size, then what do? We add the answer result dot pushback, whatever form the array was there, we add it. Okay, this is the base case. Okay, base case. Now what we do, we run the loop for int I equal to index I less than array dot size and I plus plus, and we swap. What do we swap? We swap the array index to array I. Okay, we swapped it, whatever the position was there, from 1, when the index becomes 2, then 2 will swap with the I, starting with I. Okay, so first initially 1 will be swapped with 1, so no change will be there. So again then index will increase. So here when we call this recur permute, what we do, we pass the index. Okay, this is IND, right? Okay, IND plus 1, and then what do we pass? We pass this array and result. Okay, IND plus 1 array result. So when this index will increase, so 2 will be swapped with 2. So again then index will increase, 3 will be swapped with 3, and then when the index will becomes equal to the array dot size, then we'll push the array, whatever the array is there. Okay, and then we will, once we get the answer for any of the recur permute, we will again swap array of index new value to array of I. Okay, and we'll close this, and whatever the answer we will have, this will be correct. Okay, I hope the code is clear. You can try the solution by yourself. The link to the question is given in the description, and then come to my code walkthrough section where I'll be explaining the code walkthrough. And the time complexity will be order of 2 to the power n exponential, and the space complexity, we have not used space complexity, so there is no extra space as such, just the recursive stack. Whatever the recursive stack is there, that would be the solution. But there was one more way to solve this. Instead of swapping it, we could have had a map, and we could have stored, okay, for which position it has stored, so that for which position the changing of the values has happened already. Okay, so for 1, if all the positions we have went for all the 1, and for 2 all the positions have been done, so we could have maintained it in the map, but then again extra space of map would have been done. But here just the space complexity is the extra stack space. Okay, so please check the link, try the solution by yourself, and then come to my code walkthrough section. Here is the code walkthrough of the 61st question and the first question of backtracking in the lead code platform. You can see the example and the companies that have asked these questions. You can see these are the companies. So it's a very popular question. So yeah, let's look at the solution. We have discussed the example before. So it's the same as we have discussed. We call this, and we have these things. This is the base case, and this is the backtracking logic, swapping it back after the calling the recursive function by increasing the index in the loop. And yeah, we return this after the index has been reached. The code won't go in, it won't cross. Anyway, it won't cross, it doesn't need return, but we need to return it because already the index would be greater than the size, right? So it's fine even if we don't return. Okay, so let's run it and let's submit this. Okay, so yeah, I hope the explanation is good, and see you all soon in the next video. We are explaining the 62nd question of the problem solving series and the second question of backtracking. Jai Jinendra.